Hi guys, today we will discuss about the heat transfer thermal analysis related problems. So it is a conductive heat transfer analysis of a 2D component. We just need to create a 2D component and we need to mesh and we need to apply some temperature on the one side and the other side we need to keep it as a constraint and then we need to see the results. That's it. So the we'll start. Open APDL. Just maximize this, and here we need to go with thermal analysis in preferences. Okay, preprocessor, element type, and then add, edit, delete. So select add, and then select solid quad 4 noded. Okay, in options we need to select the plane with respect to the thickness. As we are dealing with the plane thickness, we need to select and OK, and then close. Go to real constants, add, edit, delete, select add. OK, so here we need to give the thickness, that is it is mentioned 100. OK, and close this. After this, material properties, we need to give material models. Go to thermal conductivity, um, thermal. So here we need to select conductivity isotropic. Here the K value, it is 12E6, it E minus 6. Okay, and just go to 1 second. Yeah, that's it, and close this and go to modeling, create create areas. Go to rectangle by two corners, enter the coordinates. The x and y will be remains 0, so the rectangle will start from origin, and the width will be, we'll see the design. So it is the design. So dimension of the object is 2 meter by 2 meter, so we need to go with 2000 by 2000, and thermal conductivity, yeah, fine. So we'll see. So width 2000, height 2000. Okay, yeah, that's it. And we need to go to the meshing. So in meshing we need to select the mesh tool, select smart size and reduce it to 3 or 4, and select areas, set. So here we need to select pick all. Element edge length we can select 10 or something, as it is a huge body, we can go with 10 or something. And rise hidden, select mesh option here, and select pick all again. Now it will be generated with meshing. So yeah, this is how it will get mesh. After this we need to go to loads, define loads, apply. So here we need to go with thermal temperature. In temperature, we can go with uniform temperature. Enter the temperature value is 50 units. As per this one, the temperature is 50 units. Oh, it is mentioned 500 here. Okay. Is this today transfer conductor? No, sorry, it's not this one. Yes, yes, yes. Here it is. Yeah, 50 units of temperature. Uniform temperature. We need to select rise hidden. So here it will be available. Okay. So after this, and we need to select temperature on lines. At least we need to give at one edge. It should be constraint. Means the degree of freedom should be selected. So all DYF temperature, we no need of selecting anything. Okay, so now we can able to solve. If we don't give any degrees of freedom, it won't get. Okay, so go to solve current load step. Okay, now the solution is done. If we won't give any as per this one, if we go with any kind of degrees of freedom, if we won't select, okay, actually in thermal analysis we won't find defined loads, structural and related and displacement related, we won't find in the thermal analysis steps. Okay, so this is a kind of wrong notes. Okay, you just follow whatever I am telling. So this is how it will get fixed. And then go to general post processor, plot results, counter plot, nodal solution. You can go with DOF and nodal temperature, so that the entire temperature will be like this. Okay, as we mentioned, everything, uh, the temperature on the entire areas, right? So it will become like this. Okay, so if you want to see any differences, the temperature flow from this side to this side, then we need to go with preprocessor loads. Just delete the temperature. So delete all load data, all load data, uh, no, thermal temperature on areas. So pick all. Now plot, replot. Okay, now we can go with apply temperature on lines. So we can select this edge. Okay, temperature. So here if we give around 50 or something. Okay, and on lines again at this edge. Okay, if we select all DOF as well as temperature. Okay, all DOF if we select here, the temperature value if we give 15 or something. Okay, then go to solve solution, solve current load step. So okay, this is how we need to get, we need to see the difference actually. So general post processor plot results, counter plot, nodal solution, nodal temperature. Okay, so this is how it will looks. This is what you need to know. Okay, if we apply entire temperature on the area, it will be with the same temperature entirely. Okay, as per your worksheet, you won't get anything. Okay, so the result, I mean outcome from this experiment, students will be able to analyze the thermal stress of a 2D. It is okay, you will be able to know the procedure of applying, but you should know from this end to that end, the temperature should be like this. Okay, I mean the temperature is going in this way. Okay, so this is how you need to know. If you want to check this one in 3D, go to plot controls, style, size and shape. Here you need to display of element, you should turn on and click OK. So this is the thickness and this is the length and height. Okay, so that's the end of the. If you want to check the um, if you want to check a kind of temperature at each and every node, you can go with subgrid solution, DYF solution temperature. Okay, so if you click here, it will be 50. If you click here, 42. So this is how the temperature ranges from this end to that end. Okay, this is 15. The last point is 15. Okay, so this is how the temperature will flow. Click OK. Yeah, that's it. Thank you. If you have any doubts regarding this related temperature, I mean thermal analysis, you can comment on this, and if you just ask the doubts whatever you have. Okay. Thank you.